In this video, we will learn about the commands used in assessing network layout and security. Network reconnaissance tools. Network reconnaissance is a term for testing for potential vulnerabilities in a computer network. Network reconnaissance tools are used to scan the network to probe for open ports and other vulnerabilities that can be taken advantage of by the attackers to gain access to the network. What is organizational security assessment? Organizational security assessment is the process. It's the procedure of testing and analyzing an organization's existing security policy and security controls in place to determine how secure the organization is from cyber attacks. Network layout detection. The first step of performing the security assessment is to identify the organizational network layout. It is vital to understand the network architecture and the security controls in place. To do that, we need to understand a few commands. Firstly, there's the ipconfig and ifconfig command. To understand and see the network layout, we can use the following commands with respect to the operating system. In computers running Windows operating system, we can use the code ipconfig in the command prompt to view the device IP address and the subnet mask. Similarly, if you are using Linux operating system, we can use the code ifconfig in the terminal to view the network layout. Ping command. Ping command is used to test the connectivity or reachability between the devices. It is used to test or verify the connection between the host and the target machine. How does ping command work? The ping command operates by sending or pinging the ICMP echo request messages. ICMP stands for Internet Control Message Protocol. The ping command sends this ICMP echo request to the destination computer and waits for a response. It waits to hear back from the target computer or device. The two major pieces of information that the ping command provides are how many ICMP echo responses are returned and how long it took for them to return. Assume that in the network you are accessing, there's a printer and you try pinging it, but there's no response. And when you check, you find out that the printer is offline and its cable needs to be replaced. Or maybe you need to ping a router to verify that your computer can connect to it, so you don't have to worry about a potential networking issue. Ping command options. You simply type ping space dash n space count. This option sets the number of ICMP echo requests. If you use this option, you can set the number of ICMP echo requests you can send to the device. The ping command by default will send 4 ICMP echo requests if -n command isn't used. -t using this option will ping the target until you force it to stop. To stop, simply press Ctrl+C or Command+C. -a this ping command will resolve, if possible, the hostname of an IP address target. Ping command example. In this example, the ping command is used to ping the target google.com. By default, 4 ICMP requests are sent to the google.com. In this case, we heard back from all the requests, and the time it took to hear back from the target is mentioned below. Root command. In computing, root is a command used to view and manipulate the IP routing table in Unix-like and Microsoft Windows operating systems. Traceroute command. The traceroute command is a small network diagnostic software that you have built in on your device and servers for tracing the route, hop by hop, to a target. To access the traceroute, you will need to use the terminal in Linux and Mac OS. Or in Windows OS, you can use the command prompt. You can use the traceroute and see the full route that the packets take to reach their destination. Apart from that, you will see the host names and IPs of the routers on the way and the latency, the time it takes for each device to receive and resend the data. With traceroute command, you will be able to see all the routers on the way with their IP addresses and the time it took. You can better understand the network and check if you can reach the target device. You can see how much time it took in each hop. So you can see a spot that significantly slows down your network. You can fix that problem, add more presence in the area. Address Resolution Protocol. ARP protocol, in short, is a procedure that connects an ever-changing internet protocol address to a fixed permanent physical machine address. It's also known as the MAC address, Media Access Control Address, in a local area network. To put it simply, what happens is, in a local area network connection, there are devices with different IP addresses and MAC addresses. The MAC address is permanent. The router allots dynamic or ever-changing IP addresses to the connected devices' MAC addresses within the local area network. Each device forwards its data request to the router and the router fetches the results. But the problem is, even after fetching the results, how is the router supposed to know who and how to send the data packets without a means of identifying who or what devices requested for which info? The ARP protocol solves this issue. The router forwards an internet request put forward by the connected devices and fetch the request from the internet. When you're using the internet via your laptop or your smartphone, the router, it carry forwards your device's request to the server and it requests for the relevant data. And when the request, it reaches back to the router, it has to be able to identify which device asked for this router. Basically what happens is, in your home, when your device connects to the router, what happens is that the router assigns an IP address to your device's physical address. So after receiving all the information requests, the router broadcasts or asks the ARP program to find a MAC address that matches the destination IP address where the network traffic is supposed to go. After the request is made by the router within the local area network, asking who has the particular dynamic IP address linked to their MAC address, and the device with the requested IP address, it comes forward claiming that it has the matching MAC address. Only then the router transfers the data requested by the device. To sum it up, ARP broadcasts a request packet to all the machines on the local area network and asks if any of the devices are using the particular IP address. When a machine recognizes the IP address as its own, the one allotted by the router, it sends a reply to the broadcast. So the ARP can update the cache for future reference and proceed with the communication, that is transfer data packets or network traffic. A table called ARP cache maintains a record of each IP address and its corresponding MAC address. ARP table is used to keep record of the dynamic IP addresses and the device physical permanent MAC address of the devices. For the communication between two devices, it is necessary that the IP address and the MAC address of the source and the destination device should be stored in the ARP table. If there is no record in the table, an ARP broadcast is sent by the source to all the devices in a network. All the devices compare their own IP address with the IP address of the destination device. When the IP address of the device matches with each other, that device sent a response is then updated in the ARP table.